Out there in space, there is an ocean shrouded in darkness, hidden beneath miles of ice, where no light has ever reached. Strange, unknown waters stirring, untouched for billions of years, waiting. Is there something alive down there? Something alien? Our solar system may be vast, but one place has captured the curiosity of scientists like no other: Jupiter's frozen moon, Europa. For decades, scientists have looked at Europa's icy surface and wondered, could something be hiding in its depths? Could this frozen world be home to life that defies everything we know? In our quest to uncover alien life, Europa could be our most promising clue, an ocean world where the unimaginable might be lurking beneath the ice in a darkness unlike anything we've ever known. When we imagine stepping off Earth and making a new home among the stars, three main destinations stand out: Mars, the Moon, and, surprisingly, Europa, a distant icy moon of Jupiter. Each of these celestial bodies has unique qualities that intrigue scientists, from Mars' red deserts to Europa's hidden ocean. So why are these places at the forefront of our interplanetary dreams? Mars is often considered our best hope for a second home in the solar system. Unlike the harsh emptiness of most planets and moons, Mars has a relatively mild climate, at least by space standards. And crucially, there's water, frozen under the soil and at the polar ice caps. Though its atmosphere is thin and filled mostly with carbon dioxide, this red planet presents exciting possibilities for colonization, thanks to its 24.6-hour day, landforms that resemble Earth, and minerals that could one day support agriculture. The journey to Mars, though long, is feasible with current technology, and landing there seems within humanity's grasp. The Moon's close proximity to Earth makes it a perfect testing ground for life in space. At just distance of 3 days, it's the place where human colonies could be trialed before we attempt a longer trek. Lunar missions are faster, and any emergency on a lunar base could be responded to quickly, making it a valuable stepping stone for Mars. But the Moon itself presents challenges. Its surface is dusty and barren, with little atmosphere to protect from cosmic radiation. Temperatures swing dramatically, and its low gravity could affect human health long-term. Yet, the Moon remains a critical part of our future in space, a place to learn and grow before we venture farther out. Unlike Mars and the Moon, Europa isn't a place we'd want to colonize, but it's a place that might harbor life. Hidden beneath its icy crust lies a vast ocean, possibly twice as large as all of Earth's combined. Europa's icy shell protects this ocean from Jupiter's intense radiation, and scientists believe that this ocean could provide the conditions necessary for life to emerge. Rather than being a new home for humans, Europa could be the first place in our solar system where we find life beyond Earth. Its appeal isn't in colonization, but in exploration, offering the tantalizing possibility of alien organisms swimming just beneath its surface. Europa stands apart because it challenges our ideas of where life might exist. Unlike Mars, which has ancient riverbeds, or the Moon with its barren plains, Europa holds the promise of an active, hidden world teeming with possibilities. And for that reason, it's become one of the most exciting targets in our quest to find life beyond Earth. Europa's surface is a bright, icy mirror reflecting sunlight from over 485 million miles away. It orbits Jupiter, the largest planet in our solar system, and this relationship creates intense gravitational forces that shape Europa in surprising ways. Europa's unique properties have captivated scientists, as it seems to be a world where extreme conditions might still support life. As one of Jupiter's largest moons, Europa is constantly under the influence of the gas giant's gravity. This gravitational pull creates tidal forces that stretch and flex Europa's structure, generating internal heat. It's a bit like the Moon is kneading itself from within, keeping its interior warm despite surface temperatures that can plunge to minus 260 degrees Fahrenheit or minus 160 degrees Celsius. However, this orbit also exposes Europa to Jupiter's powerful radiation belts, which would make human exploration challenging. That radiation constantly bombards Europa's icy surface, creating an environment that would be deadly to humans but potentially manageable for some forms of life below the ice. Europa's surface looks nothing like the crater-pocked terrain of our Moon or Mars. Instead, it's an icy, smooth expanse, crisscrossed by dark lines, ridges and cracks that spread for miles across its surface. These features hint at an active world beneath the ice. Scientists believe these cracks could be caused by the tidal forces exerted by Jupiter, where ice plates might shift and create fissures. Some of these cracks even seem to show signs of reddish-brown streaks, which could be mineral-rich deposits or even organic materials brought up from the ocean below. Beneath this icy crust, thought to be around 10 to 15 miles thick, lies Europa's most intriguing feature, a hidden ocean. Scientists have observed what they believe to be water plumes shooting from beneath the ice, suggesting that the ocean is not entirely sealed off. If these plumes can reach the surface, they may provide clues to the ocean's composition and offer a unique way to sample Europa's depths without drilling. This tantalizing possibility adds to Europa's allure, as any signs of organic material could suggest life. While Europa's distance from the sun means it receives little direct heat, it has a different source of warmth: tidal heating. As Europa orbits Jupiter, the gravitational pull of the planet and its fellow moons stretches and compresses Europa, creating frictional heat within its core. This process, known as tidal flexing, could be enough to keep Europa's ocean in a liquid state, making it one of the only places beyond Earth where liquid water might be stable. The warmth generated from this tidal heating may even create hydrothermal vents on the ocean floor, similar to the volcanic vents found deep in Earth's oceans, which are known to support life in extreme conditions. Europa's surface is rich in compounds that could serve as nutrients for potential life forms. Observations suggest the presence of hydrogen peroxide, salts, and even some organic compounds. These substances, when mixed with water and energy, could create an environment where microbial life could thrive. Hydrogen peroxide, for instance, can react with water to produce oxygen, a key ingredient for many forms of life. The discovery of these chemicals suggests that Europa's ocean might have the right ingredients for life as we know it, or at least for life as we're still learning to imagine. The search for life beyond Earth has always fueled our imagination, but now, with NASA's Europa Clipper mission, we're closer than ever to exploring one of the most promising places for finding alien life right here in our solar system: Europa. This icy moon of Jupiter, orbiting 485 million miles from Earth, may hold a vast, hidden ocean beneath its frozen crust, a mysterious dark world that could harbor the conditions necessary for life. But getting there and uncovering its secrets is no easy feat. Europa Clipper isn't your typical exploration mission. Unlike a rover that would land and explore the surface up close, Clipper is designed for a series of flybys, allowing it to survey Europa from a safer distance. This choice wasn't just to cut costs, it's a survival tactic. Europa is situated within Jupiter's powerful radiation belts, which expose the moon to an onslaught of intense radiation. Any spacecraft attempting a prolonged stay on the surface would likely be fried in a matter of days. By sticking to flybys, Clipper can dip in close for a few hours at a time, capturing data before retreating to a safer orbit. To truly understand Europa's potential, the Clipper mission will be equipped with a set of advanced instruments designed to unlock the mysteries lurking beneath the ice. Key among them is an ice-penetrating radar that will scan Europa's crust, trying to gauge how thick the ice is and whether it conceals liquid water. This radar could reveal the ocean's depth and confirm whether it interacts with the surface, an essential factor in determining if life-sustaining chemicals can reach the water below. Additionally, the Clipper carries a magnetometer, which will measure the magnetic field around Europa, giving scientists more clues about the ocean's composition and salinity. Europa's surface is another fascinating subject. It's marked by strange maze-like cracks and ridges that stretch for miles, showing evidence of geological activity. Scientists believe that tidal forces from Jupiter's gravity flex Europa's crust, creating internal friction that generates enough heat to keep the ocean below from freezing solid. This process, known as tidal heating, could also create hydrothermal vents on the ocean floor, similar to those on Earth's seafloor, where life has been found to thrive even in darkness. Clipper will also seek out signs of water plumes that may erupt from Europa's subsurface ocean into space. These plumes are like natural faucets, potentially allowing Clipper to sample the ocean without ever touching the ground. If Clipper detects organic molecules or other compounds essential to life in these plumes, it would be an astonishing breakthrough. Of course, detecting these plumes and analyzing their makeup won't be easy. Clipper will be equipped with sensitive spectrometers that can analyze the chemical composition of any material it flies through. By examining what's in these water jets, scientists hope to understand whether Europa's ocean contains the basic ingredients for life, compounds like carbon, hydrogen, nitrogen, and oxygen. While Europa Clipper won't be landing, its journey is critical. It's a reconnaissance mission, gathering data that could someday lead to a future lander mission. A landing would be incredibly complex, not just because of radiation, but also due to Europa's thick ice shell, the unknown terrain, and the extreme cold. Successfully landing on Europa would be like aiming a dart at a target 485 million miles away through a radiation storm. But each close pass that Clipper makes brings us one step closer to that possibility. The mission is a profound leap in our quest to answer one of humanity's oldest questions. Are we alone? With the data Europa Clipper gathers, we may soon have the first hints of an answer, and perhaps a tantalizing glimpse into a hidden ocean where alien life could be waiting. Europa's icy ocean isn't just fascinating for its alien life potential, it also offers a rare opportunity for scientists to study an environment completely different from Earth's oceans. While they both contain water, Europa's ocean exists under pressures, temperatures, and chemical conditions far removed from what we're familiar with. This means studying it could reveal entirely new scientific insights. If there's life in Europa's ocean, it would have to survive in extreme conditions: pitch-black darkness, high pressure, and frigid temperatures. On Earth, we have creatures called extremophiles, organisms that thrive in hostile environments, like deep-sea vents or volcanic springs. These life forms show us that life can adapt in extraordinary ways. If we find extremophiles or similar organisms on Europa, it would demonstrate that life might be much more adaptable than we ever imagined, capable of thriving in places where humans couldn't even survive a moment. Europa's ocean likely has a very different chemistry than Earth's seas. Earth's oceans are rich in oxygen and other elements that support diverse life forms, while Europa's ocean might be high in salts and minerals but low in oxygen. By studying Europa, scientists could learn how different ocean chemistries affect life, and even discover forms of life that rely on chemistries vastly different from our own. This could expand our understanding of what's possible for life on Earth and beyond. On Europa's surface, scientists have detected organic compounds, the building blocks of life. These molecules could hint at complex chemical processes happening beneath the ice. If organic molecules exist in Europa's ocean, they may interact with minerals in ways that create prebiotic or life-forming conditions. Scientists believe that similar processes may have led to the origins of life on Earth. By studying Europa's chemistry, we could gain insights into how life might arise on other planets and even learn more about our own origins. Europa's icy world offers us more than just a chance to find life. It's a chance to redefine what life means and where it can thrive. As we look to the future, we stand on the brink of one of humanity's most ambitious quests: to seek life not on a distant exoplanet, but in the strange alien ocean right here in our solar system. What we find there might just change everything we know about life's place in the universe.